Hey guys, and welcome back to part 2 of the Hyperbolas video. So in the previous video we just took a look at these guys up here and the general translation of the hyperbola graph. In this video we're mostly just going to be going over examples on how to sketch them and pretty much stuff to do with that. So let's start with example 2. So we've got the graph y equals -2 all over x minus 1. So straight off the back we can see two things have pretty much happened. One, it's been shifted to the right, so it's been shifted in the positive region because of x minus 1, and remember that's counterintuitive. So if it's negative down here, that means it's gone the positive direction because the asymptote is going to be when this guy is 0, and when that's 0 is when x is equal to 1. So straight off the back we know the asymptote is here, x is equal to 1. We can also see this is now negative. So if we recall from the previous video, the positive curve looks like this if you have y equals just 1 over x. But since we have negative now, it's going to look like this because this is y equals -1 on x, because it takes every single y value and times it by -1 pretty much. So we know it's going to pretty much look something like this. Now, from our general sketch at the moment, we can see it's got some intercepts. It's got a y-intercept, and it's got, well, pretty much that's it. Because there's no way it's going to have an x-intercept because it hasn't been moved. The graph hasn't been shifted vertically at all. Because the asymptote, the horizontal one, is still here at at y equals 0. Sorry. So we got to pretty much find the y-intercept. So y-intercept is when x is equal to 0. So we pretty much substitute that into our equation here. So we have y equals -2 on 0 minus 1. So we'll have -2 on -1, which is +2. So that point there is 0, 2. And that's all we really need to label this graph here. And that's about it, because no other translations have been occurred pretty much. Okay, there's no vertical, only a horizontal and a reflection. Okay, let's move on to the next slide where there's a couple more examples. So 4. Sketch the graphs of the following. So pretty much, if you include your asymptotes, any intercepts, or any points, you can account for any dilation factors, because most of the time you look at them and think, oh, how can I show that this dilation factor is going to be there? It will be shown to be there because of your x-intercept, because if there was no dilation factor, your x-intercept or your y-intercept would be slightly different because you work it out from these numbers here. So let's just start with pretty much a. So y equals 1 on 3x plus 1. So at the start we can see, alright, has it been shifted at all? Well, let's work out when this is equal to 0. So when 3x plus 1 equals 0, move the 1 to the other side, so you have 3x equals -1, and then divide by 3, so -1/3. So that means it's going to have asymptote at x is equal to -1/3. So if I just put that in, so we have x and y. So we're going to have, alright, x is equal to -1/3. Okay, and we can see it's positive, so it's going to pretty much still look something like this. Now we can see, alright, it's got a y-intercept there. We can work out where that is because a y-intercept is when x is equal to 0. So y-intercept when x is equal to 0. So all we do is go y equals 1 on 3 times by 0 plus 1. So it gives me 1 over 1, which is 1. So we know that point there is pretty much 0, 1. Now, have we actually accounted for our 3 here? Well, we have with the asymptote there, because if there wasn't a 3 there, like if this wasn't 3 and that was a 1, then our asymptote would be x is equal to -1 rather than -1 on 3. So if you wanted to, you could double check that if you wanted to, like you could graph it on Desmos or any calculator, but pretty much that's pretty much all it's accounted for. So we have a horizontal, not a vertical asymptote at x equals -1/3. We do have a horizontal one, but still at the y equals 0 because there's been no translation up pretty much. So that's how you would graph A. So let's rub this out and let's take a look at B. So B is actually the same graph, except it's got -1 on the end. So what that means is we're going to take our original graph we just rubbed out and move it down by -1. So we can see we've got this same thing here. So we still got an asymptote at x is equal to minus a third, but now we have a horizontal one at y equals -1. Because if I put in -1 for y, so if I go -1 for y, and then I try and solve for x, let's kind of see what happens. So I plus 1 to both sides. So I get 0 equals 1 on 3x plus 1. So then I get the scenario where 0 equals 1, which is not true. So we have an asymptote at y equals -1. So rub that out. And pretty much we've got to draw a set of axes again. I can't believe I rubbed that out. So axes, x and y. Draw in your asymptote. So x is equal to minus a third. And y equals -1. So it's been shifted down now. So we can see it's still positive, so it's going to kind of look like this. Okay. Now I don't know if it has 2 points or it goes straight through the origin, but we can work that out. So what we're going to do is look for some x-intercepts and y-intercepts. So we'll start with x-intercepts. When x-intercepts is when y is equal to 0. So we got 0 equals 1 on 3x plus 1 minus 1. Move the -1 over here, so you get 1 equals 1 on 3x plus 1. Move this entire thing up to the other side by multiplying by 3x plus 1. So what you're going to get is, alright, let's move this to the side. Need more writing room. So what we're going to get is 3x plus 1 equals 1, minus both sides by 1. So what we're going to get is 3x equals 0, so therefore x is equal to 0. So what that means is our curve goes through the origin, because if you've set y equal to 0 and you get x equal to 0, that's pretty much your coordinate. So straight off the back, we got 0, 0. Now, if I look for a y-intercept, I'm going to get the same point pretty much, and I can double check that as well. So rub that out. So if I go y-intercept is when x is equal to 0, which will get the exact same point, but I'm just going to show you can do it either way. So you get y equals 1 on 3x plus 1 minus 1. Set x equal to 0, so that term is gone. So you get y equals 1 minus 1, so you get 0. So you get that exact same point there. Now, you don't really need to include anything else because you've included the asymptotes, which accounts for the dilation, and you've included a point on the graph. So if you were just given this graph, you could work out your equation pretty much. If given like a form, like, all right, the graph looks like this: y equals a on bx minus h plus k. You could work it out from this pretty much. Okay, so if pretty much when you're graphing, try and think, all right, have I included enough information to work out my equation just from the picture pretty much? If you can do that, then you've graphed it pretty well. Okay. All right. So we'll be using question C, which is the exact same setup, but slightly different. So question C, we have y equals minus a third, 1 on 3x plus 1 minus 1. So the only difference between these two is it's been reflected now. So our previous curve looked like this. It went through here and here. Our curve here now, because of this -1, is going to look something like this. It's been reflected. So we can see from our red curve, we've got one x-intercept and one y-intercept. Okay, so pretty much we've got to work that out. Now you'd still label this x is equal to minus a third and y equals minus 1. So now I'm going to move that in the corner, so I have enough room to pretty much do the algebra. So from the red curve, yep, we've got one x-intercept and one y-intercept. So x-intercept, set y equal to 0. So 0 equals minus 1 on 3x plus 1 minus 1. Move the -1 to the other side, so you have minus 1 equals minus 1 on 3x plus 1. So therefore you're going to get minus 3x minus 1 equals -1. So all I did was move this guy up there and then apply the -1. So that's why that's all negative now rather than this. So then you move the -1 to the other side, so you go, alright, plus 1, So you get negative 3x equals 0. So x is equal to 0. That cannot be correct. Because because our curve, there's no way that can go through the origin there because of the negative factor. Because that's the origin there. But it's been reflected. So now I'm just checking if my math is correct. Move 0, 0. Okay, so I've seen my error there. So I'm going to include this in the video because even though I've made an error there, what I did was when I moved that over there, I didn't change the sign. So that's going to be positive. So that makes that positive, and get rid of that, get rid of that. So the reason why I'm going to include this in the video is because graphically, I can see my answer was going to be wrong because I'm looking at the red curve and it said my point was here, which doesn't match with my drawing at all. So from your drawing, before you even know your x-intercepts and stuff, if you get a number that's a bit outrageous like that, you can tell you've got it wrong and you can kind of save yourself. So what we can do now is go minus 1, minus 1. So we get 3x equals minus 2. So therefore x equals negative 2 on 3. And now that matches up because it's a negative number and it's not 0, pretty much. So negative 2 on 3, 0 is that point there. Now we've got to pretty much find a y-intercept now. So y-intercept is when x is equal to 0. So pretty much do it the other way. So y-intercept, x equals 0. So you get y equals negative 1 and then x is 0 plus 1 minus 1. So you're going to get y equals negative 1 over 1 minus 1. So you get minus 1 equals negative 2. So that point there is going to be 0 minus 2. And that's it. Right, so that's question C solved. Now let's take a look at question D. Right, so question D, it's still got the same horizontal, same vertical asymptote, but this number is different. It's been dilated by a factor of 2. So that's pretty much going to stretch it vertically. So if we take a look at our previous notes, when you have this number up here, it pretty much takes your y value and times it by that pretty much number. So for example, if that was 3, then your y value would be multiplied by 3 every single time pretty much. So whatever this number is how it's going to get stretched vertically or compressed vertically. This case here, it's going to get stretched because the number's bigger than 1 and less than, negative. So we'll go y equals minus 2 on 3x plus 1. So we can see straight away we still have that vertical asymptote at x is equal to minus a third. It's negative, so it's going to kind of look like this still. So go like that. So from here we can see there's only a y-intercept, there's no other things there. This is still an asymptote because we haven't been shifted up or down in this case here like these previous examples. So we have an asymptote there, so no x-intercept. So we're only looking for a y-intercept. So y-intercept, x equals 0. So go y equals negative 2 on 3 times by 0 plus 1. So you're going to get y is equal to negative 2 on 1, which is negative 2. So this is going to be 0 minus 2. And you don't need to include any other information because you've got the asymptote and you've got this point here, which pretty much accounts for this number up here. Okay, so you have all the information you need to work out your equation from the graph pretty much. But that's how you do that one. Let's take a look at another example that's a bit trickier than the previous one. So question 6 that I've chosen from the Cambridge book is, alright, you're given this, show that's equal to that, and hence sketch this graph. So you could get given a hyperbola that looks like this. And you might be looking and thinking, okay, how's that a hyperbola? Well, that's pretty much part of the question. You need to show that this is equivalent to that. So what you need to do is pretty much a bit of long division. So what this statement is pretty much saying is, all right, 2x plus 3 divided by this. So what we're going to do is set it up like a long division question. So x plus 1 divided by 2x plus 3. Okay. So pretty much you need to work out, all right, how many times does x fit into 2x? So 2x over x twice. So you put the 2 up here, and we can see that's where that's coming from. Then you take this number and multiply it by this thing here. So you get 2x plus 2. So what you're going to get is minus 2x plus 2. That cancels with that. So you're going to get 3 minus 2, which is 1. So in other words, we can see we're not going to get a remainder here. So we can actually rewrite this. All right, 2x plus 3 divided by this is going to be 2 plus 1 divided by this still, which pretty much shows, all right, this is equivalent to that. So that's how you would do that one, because you can't really divide this anymore, because you would just start getting negative powers of x. So you'd have to leave it like this pretty much. So your remainder is 1. So you leave it as 1 divided by your expression still. Okay. So we've shown that that equals that, and now we can see, all right, that's a hyperbola, because you can see, all right, that's 1 over x something plus something. So we can take a look at this a bit further and think, all right, if that's an equation, what do we have? Well, for starters, we have two asymptotes. You've got an asymptote when x is equal to -1, and an asymptote when x is equal to +2. So in other words, let's just label that straight away. So x and y. So x equals -1, so that's going to be here. X equals -1, and y equals 2, so that's going to be here. Y equals 2. The graph is positive, so it's going to kind of look like this. And from our drawing, we can see, all right, we've got a y-intercept and an x-intercept minimum. Okay, so let's find the y-intercept. So y-intercept x equals 0. So you get, all right, y equals 2 plus 1 on, and then you replace the x with 0, so 0 plus 1. So you get y equals 2 plus 1, because 1 divided by 1 is 1, so you get y equals 3. So that point there will be 0, 3. Okay. Now we've got to find the x-intercept. So x-intercept, set y equal to 0. So you go 0 equals 2 plus 1 on x plus 1. Move the 2 to the other side, so you get -2 equals 1 on x plus 1. Then we're going to multiply both sides by this. So we'll go x plus 1 and go x plus 1. That cancels there. So now we're going to get -2 times by this and this. So we'll get -2x minus 2 equals 1. I'm going to rub some stuff out because I'm running out of room. So now we're going to move the -2 to the other side. So we'll have -2x 1 plus 2, which is 3. So x is going to be -3 on 2, which is -1.5. So that's going to be -3 on 2, 0. Which makes sense because it's a negative number and with a negative region of x. Okay? And that's all you would need to do. So you could technically go, all right, this is the graph of this, because we've shown this is equivalent to this using long division pretty much. Okay? Right, let's take out the last question for this video, and that'll be it on hyperbolas. If you have any questions at all about this topic, leave some in the comments and I'll try my best to answer them. Okay, so question 7 is exactly the same as question 6, except it's just got different numbers and different algebra. So you've got to show, all right, this is equivalent to this pretty much, and then hence sketch the graph of this. So long division on this. So this is going to be, now I'm going to rewrite it as -2x plus 3, so -2x plus 3, so I have the x leading first, divided by this, so x minus 2. So -2x divided by x is going to be -2, so place that up there, and we can see that's that first term there. -2 times by all this is going to be -2x plus 4. Take this and put it down here and subtract it, -2x plus 4. We can see that term cancels there. Then we're going to have 3 minus 4, which is -1. So your remainder is -1. So 3 minus 2x on x minus 2 is the same as -2 plus -1 on x minus 2, which is what we've shown up there pretty much, okay? Righto, so now that you've worked this out, it's in pretty much a hyperbola form, so we can take a look at the actual function itself. So, straight off the back, we've got three things. It's been reflected, it's got two asymptotes as well. So, if you have y equals 1 on x, it generally looks like this pretty much. But now we've got pretty much a negative, we've got to account for, alright, it's going to look like this now. So that one's that curve there, and that one, and this one is that curve and that curve respectively, okay? So we know it's going to pretty much look something like that. So it's going to be in quadrant 4 and 2, and it's got some asymptote. So it's got an asymptote when x is equal to 2 and y is equal to minus 2. So we draw pretty much an x-axis and draw your asymptotes first. So y equals negative 2, which is going to be down here, and x equals 2, so it's going to be here. Right, so it's negative, so we know it's going to kind of look something like this pretty much. So from our drawing, we've got pretty much a couple scenarios. It's either going to have an x-intercept and a y-intercept, or it might go through the origin here, so it might look like that. But we can double check that when we find one of them pretty much. So first of all, we can look for just x-intercept. So x-intercept when y equals 0. So you go 0 equals minus 2 plus negative 1 on x minus 2. Move the negative 2 to the other side, so you get 2 equals minus 1 on x plus 2. Going to times both sides by x minus 2. So that term there will cancel. Then you're going to distribute the 2 here. So you're going to get 2x minus 4 equals minus 1. I'm going to rub some stuff out because I'm running out of room. Move that. Then I'm going to move the negative 4 to the other side, so I'll get 2x is equal to negative 1 plus 4, which is going to be 3. So 2x equals 3. So therefore x is going to be 3 on 2, which makes sense because we're expecting a positive x value. So this is going to be 3 on 2, 0. So since this isn't 0, we know there's going to be a y-intercept now. So y-intercept, exact opposite thing. So if you want a y-intercept, you set x equal to 0. So y-intercept, x is equal to 0. So you go y equals minus 1 on 0 minus 2, minus 2 as well. So all I did was make that 0. So I get y equals negative 1 divided by negative 2 is going to be positive a half minus 2. Now I can work this out without a calculator because 2 is the same as 4 on 2. So I can change that and go y equals a half, positive a half, minus 4 on 2. Now they have common denominators, so we're going to have negative 3 on 2 because 1 plus minus 4 is going to be negative 3 and the denominator remains the same. So that's going to be minus 3 on 2, 0. And that's pretty much the graph. You've got your asymptotes and you've got your points. So it accounts for pretty much these numbers here. Okay? And that's the final video on hyperbolas. If you have any questions about anything we've covered in this video or a previous video, please leave something down below and I'll try my best to answer it. Thank you so much.